Hello and welcome to this special edition of the EXARC Show. The 14th Experimental Archaeology Conference took place in May this year in Curitiba, Brazil. It marked the first EAC event to be held outside of Europe, so very exciting on multiple accounts. Many of the conference presentations are still freely accessible on our EXARC YouTube channel. As an introduction for some of you and a replay for others who attended the event, we've created a compilation of the presentation's introductions. In order to preserve the visual element, we decided to produce a movie version this time, rather than an audio-only podcast. The sessions focused on different materials: lithic or stone technologies, organic technologies, ceramic technologies, and metalworking technologies. The diversity of the projects, as well as the nationality of the speakers, highlighted the increasing depth and connectivity of the international experimental archaeology community. We hope that you will enjoy this quick recap of these engaging presentations. In the first set, you will see 5 presentations on lithics and stone technologies from Brazil, Norway, and the Netherlands.
Hello everyone, my name is José Lucas Couto and I'm happy to be presenting my research titled Techno-Experimental and Functional Approach to the Lesmas of the Itaparica Tradition, Central Brazil, Serranópolis. It's especially nice to be back with a follow-up of my last presentation titled The Slugs of the Itaparica Tradition, an Experimental Approach, where I present the technological reproduction of the Lesmas that we use on this current research. Well, the Itaparica tradition is an important archaeological culture marking the earliest widespread human settlements in Brazil and potentially extending into other regions of South America. Spanning approximately from 12,700 to 7,400 years BP, the Itaparica tradition represents a significant hunter-gatherer culture and technological phase during the transition from the late Pleistocene to the early Holocene in Brazil. Within the red circle is Serranópolis, located in the southwestern region of the state of Goiás. It's one of the most significant areas associated with the Itaparica tradition and the current reference point for our experimental research. The map you see highlights with black dots the distribution of archaeological sites featuring unifacially napped tools or lesmas dated earlier than 8000 BP. Although bifacial tools were also produced, the Itaparicas are best known for its distinctive unifacial lithic artifacts, particularly the lesma.
Hello everyone, my name is Rafael Antunes Novaes Carvalho. Today, I will be presenting the results of a cutting-edge experimental archaeology project conducted under the guidance of Professor Dr. João Carlos Moreno de Souza. Our work focuses on the fracture formation in lithic projectile points from the RSLN-01 archaeological site, also known as Abrigo das Piás. The primary objective was to produce a reference collection of traceological fractures using the bow and arrow as a propulsion method. This dataset will serve future comparisons with archaeological points from the site. Our secondary goal was to contribute to Brazilian experimental archaeology by creating the first local reference collection for impact fractures, a key step toward strengthening traceological studies in South America.
Hello everyone. Today I'll be presenting research conducted in southern Brazil in the states of Santa Catarina and Rio Grande do Sul, an area increasingly central to our understanding of early human settlement in South America. In recent decades, numerous early sites dating to the Pleistocene-Holocene transition have been discovered in the Rio de la Plata basin, suggesting that major river systems like the Uruguay River facilitated rapid exploration and occupation. Traditionally associated with the Umbu tradition characterized by small bifacial point, recent findings now point to a more diverse and regionally variable picture. In the Foz do Chapecó area, for instance, bifacial points are rare, and instead we observe a wide variety of lithic tools and production strategies. Much of this research only began in the 2000s with salvage archaeology during dam construction.
Hello everyone and welcome to my presentation. I will be telling you about part of my ongoing PhD project on the so-called coffee bean sinkers of late Mesolithic West Norway. First off, you may be wondering what on earth a coffee bean sinker is, so let me tell you. This artifact type is, as far as I know, unique to West Norway. Around 600 of them have been found so far, and you can see the fine distribution on the map here. They have been found mainly in late Mesolithic contexts, as well as some mixed late Mesolithic, early Neolithic context, and as stray finds. They thus belong to a fisher-hunter-gatherer society, with emphasis on the fishing. These objects are made of various types of soapstone. In their most typical form, they are more or less oval with a lengthwise furrow all around. You can see an example of this basic type on the bottom right, and this is where the coffee bean nickname comes from. However, as you can get some impression of from the other examples here, there is a lot of variety in shape and engravings. They also vary in size, but mostly they are quite small. As you can see on the graph here, the vast majority weigh less than 3 grams and weights over 20 grams are rare. However, although I have cut off this graph at 30 grams, there are also some bigger examples, even over 100 grams. There has been some debate over the function of these objects, but the commonly accepted interpretation is that they were used as line sinkers, so to weigh down a fish hook to get it to the desired depth in the water. So this is what the complete fishing tackle may have looked like. The proposed alternative interpretation was that they were instead used as pendants, because they are often so small and sometimes very pretty. I don't have a physical reconstruction of that to show you, so instead please enjoy my digital artwork.
Welcome everyone, and thank you to the conference organizers for having me here today. And today we'll present on the importance of recycling of flint axes in the Vlaardingen culture period based on a series of experiments that we have conducted. The experiments I'm presenting today have been conducted as part of the Putting Life into Late Neolithic Houses project. Because people had limited access to raw materials, we see that recycling played an important role in the technological system of the Vlaardingen culture. Especially flint axes were frequently recycled. It's been estimated up to 10 or even 20% of the flint on some of these Vlaardingen culture sites consists of recycled flint axes. So these axe fragments formed an important contribution to the lithic assemblages on these Vlaardingen culture sites. Axes were flaked, and these flakes were turned into a wide variety of tool types, such as scrapers, borers, strikelites, and also ad hoc sickles, as you can see in the drawing on the right. It's important to note that these axe fragments and the tools made from these axe fragments can be recognized because they have a remnant of the outer polished surface of these axes.
The next set of 7 presentations concerns organic technologies, bone, teeth, wood and leather, with presentations from Brazil, Spain, the Baltic region, Central and Eastern Europe and the United States.
Hello, my name is Julia Camargo and I'm an undergrad student at the Federal University of Rio Grande. And today I'll be presenting my research titled Analysis and Experimental Replication of Bone Artifacts from the Central Coast of Rio Grande do Sul, Brazil. So, as the name suggests, this research focuses on the understanding of objects made out of bones and antlers found in 4 archaeological sites that are located closely to one another. It analyzes the different types of artifacts and their manufacturing process with the aim of defining the chain opératoire behind it. This is an ongoing work, so all of these are partial results. The main hypothesis is that given the proximity and likenesses in between the sites, the 4 of them would have the same or at least similar technology when it comes down to bone-made artifacts. To start this presentation, I would like to tell you a little bit about the archaeological sites and the places where they are found. 3 of these sites, Ondina Brasil, Negrinho de Oliveira, and Newton Dutra, are cerritos, mounds usually found in marshy environments with great morphological complexity, varying in shape, size, and height. They are spread across the south of Brazil, eastern Uruguay, and Argentina. The construction of these sites is attributed to the Charrua, Minuano, and Guarani groups. The 4th site classifies as a shell mound. They are monumental man-made heaps of shells. But alongside the 2 shell mounds that stand out in the landscape of the Casca site, it is possible to identify a 3rd mound that stratigraphically is more similar to a cerrito. Casca and Negrinho de Oliveira have been dated approximately 2,000 years before present.
Dear all, my name is Architect and with the chance of presenting to the 14th Experimental Archaeology Conference, I am about to present the preliminary results of our ongoing experimental project concerning the understanding of labial striations on dental remains. So, dental microwear analysis is the analysis of the non-pathological loss of the dental tissue, which can be attributed to dietary habits or paramasticator activities. So, concerning paramasticator activities and generally the reconstruction of behavior, the archaeological record has proven that the conduction of an activity using the mouth has been an important element throughout the human lineage from as early as the early Pleistocene. And we can understand and detect the specific activity that was conducted using the mouth, since each one results to a different dental feature. So we have the use of the mouth as a third hand for the stabilization of an object. We have enamel chipping, which occurs from the tearing or searing of an object in the enamel surface, while we have grooves, which indicate generally the toothpicking behavior.
Good afternoon. The topic of my presentation is tubular bone artifacts from Eneolithic sites in Central Europe. My research examines whether the bone specimens may have played a role of sound generators. However, this presentation is limited to the aspect of the digital sound reconstruction using a group of bone tubes attributed to the Neolithic early Bronze Age corded ware culture. During an experiment, we used CFD simulation. CFD is a branch of fluid mechanics that uses numerical methods to solve fluid flow problems. It is also applied during studies of gas mechanics. In this case, the non-destructive nature of digital sound reconstruction also is significant. Each step of analysis based on digital models. The aim of the project was to determine the pitch and sound intensity of models of archaeological edge fluids as a function of airflow velocity. The project involved several stages, including physical testing and modeling of 3D digital versions of the artifacts. The measurements were conducted at the Laboratory of Working Machines and Fluid System Diagnostics at Wrocław University of Science and Technology.
Hello everyone, my name is Karolina Kasperek. I am a student at Nikolaus Copernicus University in Torui, and the theme of my research was just perforators and oils on the possibility of identifying the two tools among prehistoric bone artifacts, experimental and traceological research. The main purpose of the research I have done was to decide if it's possible to identify tools used to make the tooth and differentiate them from other similar artifacts. But the question is, why? The main source we have knowledge about this type of art in prehistoric times are, of course, mummies. They are not ideal because the skin is preserved in specific conditions. This is why you have not so many examples of those marks on the skin, such as you'd see the Iceman or Egyptian ammonite pieces. Also, we need to acknowledge that when someone fights about spike type 2, there's assumptions about it being a needle for sewing or perforating. It is completely understandable, because if we do not have many sources or, let's say, evidence about tattoo practices, then the facts will not be stated as something purpose was making marks on skin. Today, we do not know how people from prehistoric times were tattooed. If that the main source of information is ethnology research, and places where tattooing is playing a really important part in culture.
Good morning, everyone. My name is Justyna Orłowska, and on behalf of my teammates, I would like to share with you a brief report on our recent experimental work related to osseous barbed projectile points and new insights into early and middle Holocene hunter-gatherer fisher hunting techniques. The project analyzes collections of osseous artifacts from the most important sites in this part of Europe. The primary goal of these studies is to build a comprehensive understanding of how products made from osseous materials, such as bone, antler, and animal teeth, were manufactured and used by hunter-gatherer fisher communities, Mesolithic and subneolithic, inhabiting the area of the East Baltic Plain, territories of Lithuania, Latvia, Estonia, and the northeastern part of Poland. In the early and middle Holocene, we are examining both artifacts from museum collections, which originate from previous excavations, as well as those currently being discovered in ongoing excavations, like those from sites in Cucuteni and Grande in Lithuania.
Hello and greetings from Poland. My name is Grzegorz Osipowicz, and the title of my speech is Wooden Sleeves from Subneolithic Sites in Szwentoj, Lithuania. What was the function? The complex of sites at Szwentoj, in Lithuania, was discovered in 1966 during irrigation works carried out at the region. Human occupation phases at different sites were C14 dated to different periods. However, all of the artifacts discussed here come from the sites dated subneolithic, the period between 3200 and 2500 Cal BC. These sites were interpreted as habitation sites, refuse layers, fishing stations, and possibly pile-dwelling settlements. Excavations carried out at the sites in Szwentoj led to collect a rich number of artifacts from organic raw materials, a large part of which were various types of wooden products. Here you can see the examples of wooden artifacts discovered in Szwentoj, like pestles, lace prongs, shafts, paddles, handles of vessels, sinkers, bows, and arrows.
I'm Natalie Roy. I teach Roman technology, myth makers, and Latin to teenagers in Baton Rouge, Louisiana, USA. My students reproduce the products and processes of ancient Roman daily life through STEM challenges, hands-on history labs, and experimental archaeology projects. During the pandemic, I watched a lot of lectures about the classical world as organizations were trying to stay connected to their members. My favorite lectures were from the Archaeological Institute of America because archaeologists talked about objects they dug up and studied. I was stunned by a lecture that Dr. Beth Green gave on the archaeological site of Vindolanda on Hadrian's Wall in northern England. In this lecture, she talked about the extensive leather collection that had been gathered at the site, and she explained how the anaerobic quality of the soil at the site preserves leather nicely. She showed numerous slides of Roman leather shoes that had been excavated. I was hooked, and I had a million questions. How are the shoes constructed? How is the leather sourced? Whom do the shoes belong to? I became so obsessed, in a good way, with these questions that I started to research Roman leather shoes, reading all the research of Dr. Green. This positive obsession led me to apply for a teacher scholarship that allowed me to design my own archaeological tour of the Roman sites in England and Wales, including, of course, Vindolanda. This site emphasizes its famous shoe collection with signage and souvenirs, including this one at the entrance of the museum. It was during one of my visits to this site on the trip that by total serendipity, I met Dr. Beth Green after she had just excavated the sole of a Roman leather shoe. When I began to tell her that I wanted to teach my Roman technology students how to make leather shoes, she asked if I might partner with her and her research assistant to experiment with lessons they wrote.
Next, we move on to ceramic technologies, with 9 presentations from South America, the Baltic region, Eastern Europe, Ukraine, and China.
Good afternoon, my name is Lucia Rombolá and I am a master's student at the Universidade Federal da Fronteira Sul in Brazil. The area of study of this project is southeastern South America, where modern-day southern Brazil, Uruguay, Paraguay, and northeastern Argentina are. The selection of this area comes from my master's project on the Guaranis, their relationship with other groups, and environment through the historical fonts of the first Europeans that arrived at America. In this area, there were multiple societies with diverse ways of life and relationship with the environment. This included hunter-gatherer groups as well as groups with varying levels of early agriculture. Archaeological units were developed to group the material culture of different human societies. As an example, and to relate later with what I will be analyzing, I will show a map of northeastern Argentina, where we can see the Itaparica, Guarani, Goya Malabrigo, and hunter-gatherers archaeological units. From the arrival of the Europeans on the American continent in the 16th century, we begin to find written records containing detailed descriptions of the peoples who lived there. In the area considered in this study, European presence was predominantly Spanish and Portuguese. Specifically, in southern Brazil, the earliest presence was Spanish, but the Portuguese crown eventually asserted dominance. This shift has resulted in the initial evidence of contact being less frequently analyzed in Brazilian academic contexts. Therefore, the historical fonts I mainly work with are Voyage to Rio de la Plata, Paraguay and Brazil, written by Ulrich Schmidl, the commentaries of Álvar Núñez Cabeza de Vaca, written by his secretary Pedro Hernández, and Natural History of the West Indies, written by Gonzalo Fernández de Oviedo y Valdés. Good afternoon, my name is Lucia Rombolá. I am a student at Universidade Federal da Fronteira Sul in Brazil. The title of this presentation is Ceramic Perforation Techniques in Hunter-Gatherer Sites from the Lower Paraná Wetland, an experimental approach. The aims are to evaluate the methods by which the hunter-gatherers of the Lower Paraná Wetland made perforations in their ceramic vessels. For that reason, we analyzed the perforated ceramics from the archaeological sites, and we conducted an experimental design to reflect on the technological choices, the effectiveness of the tools used for this task, the different ways of using them at different drying stages, and the traces left at the ceramic vessels. The manufacturing process stages, shape, and decoration have been the focus of ceramic research. However, some aspects of the technology, such as perforations and suspension holes, have received less attention. The same happened with the tools involved in the manufacture process, because sometimes they were unmodified objects that were difficult to distinguish from unused ones, or maybe they were not preserved in the archaeological record.
Hello everyone, my name is Maria Kurant and I am a student at Nicolaus Copernicus University in Toruń, Poland. Today I would like to present the results of my archaeological experiment and research regarding temper of animal and human-related origin in prehistoric ceramics in the light of experimental, traceological and physicochemical studies. The problem of identifying various types of temper of animal origin and related to a human body in prehistoric pottery is of great importance for research on the technology of pottery from this period, including primarily the Neolithic and subneolithic, but also for studies on the spiritual culture and manifestations of ritual behaviors of early Holocene communities, which, as has recently turned out more often, were expressed in temper used in pottery. Studies on organic temper have largely focused on admixtures of plant origin due to the fact that they appear in pottery much more often than those of animal origin, even accidentally as a result of clay contamination. This topic has already been discussed in literature, but the degree of its development should undoubtedly be considered insufficient because so far only basic types of temper, such as bone or shells, have been analyzed in very general terms. Other types of temper, for example meat, blood, hair, nails, wool, antler and feathers, have not been thoroughly studied so far, and their possible use by prehistoric societies has not been verified in any way, both at the level of experimental research and analysis of historic materials. Moreover, the research conducted so far was usually of individual cases, sometimes presented as a curiosity, and was often conducted within a considerable time span, which is why the current knowledge on this field is very dispersed.
Hello everyone, my name is Natalie and today I will present the results of an experimental study exploring the physical and mechanical properties of ceramics to better understand how raw materials were selected for prehistoric pottery production in Croatia. The pottery making process begins with a crucial step, selecting the right raw materials. This choice directly affects the quality, durability and performance of the final ceramic product. Several factors influence material selection, including local availability, technological requirements, and the desired properties of the pottery. Archaeological and ethnographic research suggests that communities primarily use locally available raw materials sourced near settlements or production sites. Recent research on prehistoric pottery in Croatia has shown that one of the most commonly used and readily available materials was sandy clay, naturally rich in mineral inclusions such as quartz and feldspar. However, inclusion-poor or fat clays containing fewer fine mineral inclusions were also used, though less frequently. This is particularly evident in the lowland regions of continental Croatia, where alluvial plains deposited a variety of clay types. Inclusion-poor clays formed under low energy conditions or through prolonged transport and sorting, resulting in higher concentrations of clay minerals. While this increased plasticity made the clay more challenging to work with, such clays were still used in prehistoric pottery production. The reasons behind their selection, however, remain unclear and require further investigation.
Hello, my name is Andrea Kudelic. Today, I will present the results of a research on reconstructing the incrustation technique, a post-firing method used to decorate prehistoric pottery in Croatia. The white paste inlay or incrustation is a distinctive and widespread pottery decoration technique, particularly popular within the Carpathian Basin. It involves applying a white paste into engraved motifs, creating striking contrast against dark pottery surfaces. In Croatia, this long-standing tradition began in the Middle Neolithic and continued through the late. However, it became most prominent during the Copper Age, especially in the Kostolac and Vucedol cultures. It is also characteristic but less prevalent in the Bronze Age, especially for the Pannonian complex of encrusted pottery, and it's less common during the early and the late Bronze Age. Initially, research on this technique focused mainly on stylistic aspects. However, recent advancements in analytical methods have shifted attention to its production process and material composition. Studies across Europe reveal regional variation in raw materials. In northern Italy, inlays were typically made from talc and bone powder, while in the Carpathian Basin, inlays was composed of calcite, hydroxyapatite from bones, and aragonite from mollusk shells.
The Cucuteni culture, part of the Irish Cucuteni culture complex 5-4 millennium BC, extended over a territory more than 355 square kilometers across present-day Romania, the Republic of Moldova, and Ukraine. Known for its large settlements and for its painted pottery of high artistic and technical quality, this prehistoric civilization left behind remains that continue to interest specialists and the public. The study of Cucuteni culture began with research at the eponymous site of Cucuteni Cetățuia, Iași County, Hubert Schmidt excavation on fortified plateau Cetățuie, and also in the open settlement in the valley at Dâmbul Morii, Băiceni, laid the basis for its relative chronology. Schmidt defined the Cucuteni A and B phases, with AB as transitional, observing stratigraphy and stylistic difference between two locations, which he interpreted as successive settlement stage of the same community. On Cetățuie in phase A, in the valley at Dâmbul Morii in phase AB, and back on Cetățuie in phase B. Besides the painted pottery that has dominated studies of the culture, another distinct ceramics type consistently appear in site assemblies. Type C pottery. From the earliest research, it attracts some interest, being considered by Schmidt a foreign element, possibly an import from North eastern areas characteristic of the end of phase B and primarily using for cooking.
Over the past decade, our research team has been engaged in a series of experimental archaeology projects aimed at reconstructing and testing Eneolithic ceramic kilns inspired by the Cucuteni Type culture. These experiments have provided valuable insights into the construction techniques, firing efficiency, and operational challenge of prehistoric kilns. Our efforts have led to the successful reconstructions and testing of the 3 outdoor kilns, each refining our understanding of ceramic technology in the late Neolithic period. More recently, this accumulated knowledge has been applied to the construction of a full-scale museum kiln at the History Museum of Piatra Neamț, an indoor installation designed to bring our experimental findings to a wider audience. The present discussion focuses on the interactive process of building and using these kilns, drawing upon 3 major experimental projects and subsequent laboratory analyses that allow us to determine firing temperatures and assess ceramic properties post-experimentations. Additionally, we will explore how these experiments culminated in the creation of the museum kiln, which now serves as a tangible bridge between academic research and public engagement, offering visitors a direct experience of Neolithic ceramic production techniques.
Good day, dear colleagues. Today I want to present the result of the archaeological experiment of recreation, the main work tool of the backside cut technology of tile production. The Roman technology of tile production is the most well-known method of the building ceramic manufacturing in the ancient world. We understand how it functions, its tools and ways of transformation into other analogous technologies. It has been investigated organization of Roman military tile production and civil manufacture. The tools of Roman tile production technology are well known and consist of wooden frame and different types of knives that had used for different cuttings and for molding of side flanges. In the Mediterranean and the Black Sea region, there is another, more technologically advanced method of tile production. Produced with building ceramics, has common features as imprints of parts of matrix boxes and relief decorations.
Dear colleagues and friends, I'm Bangchen Tang from China. The topic of my report today is a procuration workshop by the fair, a study of the pottery tuyères discovered at the bronze casting sites of the Shang dynasty in China. As is known to all, many tuyères used in the bronze melting operations have been unearthed in different regions of Russia, such as Cyprus, Egypt. In the Bronze Age of China, a large number of the tuyères has also been discovered. How were these tuyères used? Is there any connection between their shapes and functions? Are these tuyères also related to the common phenomenon at the bronze casting sites of the Shang dynasty in China? Through the methods of experimental archaeology, I will reconstruct different types of pottery tuyères and use them in the in-bronze melting operation to approve and try to answer these questions.
And last but not least is a presentation about metalworking technology from Lithuania.
Hello, my name is Andra, and I am very excited to introduce the project Turning Bog Iron Ore into Gold, which revives the historical craft of iron metallurgy in Lithuania. Over the past several years, we have combined education with hands-on experimentation. Our activities include not only impressive iron smelting demonstrations in the spirit of living history, but we also conduct scientific testing, metallographic research to evaluate the efficiency of our smeltings and compare our result with archaeological findings. So in this presentation, I will first discuss the type of ore available to us. Then I will outline the smelting parameters used, and finally I will present the outcomes from our 10 experimental runs.